the question asking here is, okay, the first mechanism, reactants, delta or H mu, you form a product, okay? The question asked was initiation, which step 1, initiation. I'll use a different color, okay? In my class, initiation is chlorine form radicals. This is on note 7, okay? This is on note 7. This is on note 7. And the second step, okay, you have a bunch of, okay, you already formed the chlorine with a green radical here. Initiation is basically the formation of your radicals. But this one is not in your reactant, which we're only showing you, okay, if we want to have the final product, okay, what's our reaction, okay? I'll just write the reaction, I feel like, okay? Okay, CH4, Cl2, okay. What does it form? It forms CH3Cl and HCl, right? Okay, none of this has radical, right? They don't have radical, okay? Your final product, okay, no radical. But this reaction is formed with the formation of radicals, right? So you need to show how your radical form out and how your radical react. And the third step, okay, propagation, the second step. And the third step would be how your radical disappear, which, okay, so I'll write like a, okay, initiation is how radical form. Propagation is your radical do the thing, do the reaction. And the termination is how radical disappear. On my note, it's not quite right to write those things. So that doesn't look something like should be on your textbook or your notes. So this is like a wording. We just explain things like this. Are we good? But overall, your reactant should not have any radicals because this should be disappearing. Are we good with what we're talking about?
It's cancel out.
Yeah, it's cancel out. And you're asking, well, there are so many combinations of canceling out, which later I can use a different example though. If it's not CH4, okay? If it's not CH4, that's actually will be, okay, today's note, okay, note 7, note 8, we look into, okay, that's what we did today. Note 8, basically we only need to look into what happened with propagation with 4 different, right? With 4 different diagrams. If it's not chlorine, if it's bromine, what happened with that? We only compare this, but we're still only in propagation step. We did not touch this one. This one I only showed a table. That's why I don't want to confuse anyone. Are we cool with that? I will record. If you have specific questions.
Oh yeah, I'm cool.
I record. I will post.
I think I'm in the wrong like.
Oh, okay, okay. Oh, okay. Never mind. Oh, this is yeah. Okay. All right. So are we cool with what we're doing? Okay. And then are we cool with your yeah?
For the termination step, do you want us to, like on an exam, do you want us to write out the different things, the radical?
Okay.
Different
In your exam, I will only ask the termination of one product.
Okay, so not like the other two.
Which in your question, I will specifically specify which one.
Okay.
Okay. Because I know there are so many of them.
Yeah.
Okay. Since we're here, let's do one more because that might be help. I know I use methane. Okay. Let's do this one. Okay. Okay. Do this one. Am I good? I do a little bit long on initiation on this because anyway, this is related to your exam. Are we good? Okay. Which I'll sure to do all of those, but since we're here, we'll do a little bit more of this. Yeah. Are we good? Okay. So okay. So this one. The initiation was still the same, right? Okay, what's wrong with the propagation? Now, because there are so many different, okay? There are so many different. You have, now you're good with, this is a secondary hydrogen. Okay, I'll use color red, okay? This is color red, and this is color purple. And this is purple hydrogen, right? So you have so many different, which in this case, you already can write a different one. So I'll just write, so more of this will be on note 9, okay? More of this will be on note 9, but if you are practicing mechanism, we are still not 7, okay? We can just do a small practice with mechanism writing, which I hope everyone can do that, okay? Okay, I'll use the same color, which is, I'll write the secondary first, okay? Now, this is the red hydrogen. Your mechanism writing, okay? Didn't we form a chlorine, right? Your chlorine with a green radical, right? Okay, now we are going to use another different color. Yeah, we do. Okay, so your bond, you should start with bond or electrons. Always end with single arrow, okay? Because we are doing radical. Are we cool with this?
Yes.
Okay, and then, sorry. Oh, yeah, that's correct. Yeah, you're right, sorry. Because we're forming a bond between H and Cl. Yeah, good catch. And this is a secondary radical. The reason it is secondary because it's bound to two carbon neighbor, right? Okay, and you form red hydrogen, orange Cl with a blue bond, right?
Yeah.
Are we cool with what we're doing? Okay, this is one way of doing that, which in the other way, okay, I use purple. Okay, I'll keep using purple then, okay? When you have one of the tertiary hydrogen, okay, and your chlorine, I just put the radical here, it's fine, okay? So this way it's formed, I'll write here, okay? Primary, yeah. Did not wake up, don't ask. Too early of the class, Okay. It's amazing that I did not make typo into this class. Now there are typo all over the place in the, okay. All right, so now are we all good with what we're doing here? Termination is, okay, how many radicals we have? 1, 2, 3. You mix and match as long as they close. Didn't you ask why HCl is not? Because we already formed HCl here, right?
We form HCl in which part?
In propagation.
1 or propagation 2?
2. It's, I'm not, when you write mechanism, we don't look into propagation step 1 or step 2. Because when you write mechanism, it's kind of like, that's the whole thing it formed. The transition states, it all happens in this one step. Which means, okay, let's do this, okay? What we are doing in note 8, okay? In note 8, we look specifically, okay? Note 8. We look specifically in this step to see how your hydrogen and chlorine actually form. That's the first transition state I showed, like your blah, 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 H, blah, 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 Cl with that, right? So this one in note 8 was only, we only look into this class. And we are comparing if it's not chlorine, if something else, what's the difference? Are we cool with what we're doing in today's class?
Yes.
Okay, which has nothing to do with everything else. We only look into what if it's chlorine, what if it's not chlorine. In class on Monday, we're looking into if it's primary radical, secondary radical, tertiary radical, what's the difference? Okay, so on note 7, we told you that's the whole thing. On note 8, we look specifically into this step what if it's not chlorine? On note 9, which is next Monday, we look into what happened with my secondary and tertiary radical. Are we cool with how this course is being taught? Yes?
Sorry, just making sure. So if it wasn't chlorine there, would the mechanism, if it was like fluorine, would the mechanism look completely different?
They will be the same, but my expectation from note 8, that's why note 8, you did not write any specific mechanism. You are only comparing, okay, who is faster, who is...
Like energies.
Yeah, yeah.
Okay.
Your expression from note 8 is more or less a deep understanding of this specific step, which you should know. The take-home message is iodine doesn't react. Everything else react. Fluorine doesn't need heat because in fluorine, okay, recall our energy diagram in today's class. Your fluorine only need a small amount of energy, which means in propagation step, this is so fast for fluorine. Well, for chlorine or bromine, you still need to heat it up. Okay, that's the take-home message. Overall, we are just zoom into this in today's notes. Did we make this point clear? Okay. Are we good? Yes.
Is there a reason why fluorine is more reactive? Like, is it because it's more electronegative?
Yeah. You mean? Oh, yeah. Okay. One thing is more electronegative. Another is well, just take electronegative for now. Yeah, I'm not going to ask you why. There's no free response. Knowing this would be good enough. Okay, you just need to know there is a very small of energy. Okay. Are we all good with this? I'll stop the video.
So I mean, in this writing, it's like